Hey class, another video. This video is on 13.3, and we're going to talk about the unit circle, and we're going to talk about radians. So the two objectives for this video will be to convert angle measurements between radians and degrees, and to find the values of trigonometric functions on the unit circle. All right, so here is the definition of radian, but for simplicity, a radian is just a different way of measuring angles. And I'll show you by using this circle below here. Now, I'm going to draw a point here in the center. And remember our initial side of angles when we just had the coordinate plane? It's the same for unit circle. Okay, the difference is that in the unit circle, the radius is going to be considered 1, so r is going to be considered 1. Radians is the measure of the arc here. So instead of measuring the angle right here, like for example, we'd call that 30 degrees, we'd be measuring it by the arc it makes based on a radius of 1. So let me explain a couple of things to you really quick. At the initial value here, radians is equal to 0, and degrees is also equal to 0. Since the circumference of a circle is defined as 2 pi r, if r was equal to 1, the total circumference around would just be 2 pi. So all the way around the circle, which is 360 degrees, would be also called 2 pi radians. So a fourth way across the circle, if you just look at the fractions, would be pi over 2. Halfway around the circle would be pi. And so 3/4 around the circle would be 3 pi over 2. Now keep in mind, all the way around is 2 pi. So it's just a way, you can describe angle measurements in degrees, or you can describe in radians. And we'll talk about this more, and we'll break down more angle measurements as we go on. Okay, so converting between degrees and radians is fairly easy. You just have to have a conversion factor. And the way I always look at this is, if you want to end, you want the end of conversion in radians, you want the pi on top. If you want to end the conversion on degrees, you want the pi on the bottom, because the pi's will cancel out. Let me explain what I mean. This is just a conversion factor. So a pi is equal to 180 degrees. We talked about that with the unit circle, right? So all the way around is 2 pi. So halfway around the circle would just be called pi. But we also know that as 180 degrees. So this is just the same thing. It's equal to 1. So to convert from degrees to radians, or radians to degrees, we just multiply by this conversion factor. If we want to leave the answer in radians, so we want the pi on top, because radians are in pi's. If we want the end to be in degrees, we'd want the pi to be on bottom and end up with degrees, and the pi's would cancel. Let me show you. So example A wants you to convert from degrees into radians. So we want it to end up in radians. So we want pi to be on top. So we're going to use this conversion factor here, and then degrees will cancel out. So it's really that simple. So I'm going to multiply 60 times the conversion factor with the pi on top, because your answer will end up in pi, over 180. So negative 60 would divide into 180 as negative 3. So your answer is just pi over negative 3. You see, the answer ends up being in pi, which are radians. Let's look at the other example here. It says to convert radians now into degrees. All right, so we have radians in pi, but but we want to leave the answer in degrees. So which one of these are we going to use? We're going to use the second conversion factor here because we want the pi's to cancel. Let me show you what I mean. So I'm going to multiply this by the conversion factor 180 over pi. And you see what happens to the pi's. They divide into each other, they become 1. And you're just left with 2 times 180 divided by 3. And that just ends up being 120 degrees. So pretty simple. So we're converting from degrees to radians, you want to use pi over 180 to convert them. If you're converting radians into degrees, you want to multiply it times 180 over pi. You try these on your own, and then come get me for the answers. All right, so here's the unit circle, and we're going to talk more about this in class. But to explain this, you know that sine is equal to opposite over hypotenuse, right? So if you look at the unit circle, I'm going to drop a right triangle here, and I'm going to look at this reference angle here, theta. You see that the opposite here, the opposite of theta, will be associated with the y. The adjacent of theta here will be associated with the x. And since the hypotenuse is 1 in the unit circle, then sine's just going to be associated with the y, and cosine will just be associated with the x. So this point here at 30 degrees has, I'm just going to blow this up a little bit, at 30 degrees, if you look at it here, the x value here is going to be cosine, and it's going to be the square root of 3 over 2. The adjacent side, the opposite side, is going to be sine, and that's your y value, and that's 1 over 2. And the x is going to be your cosine, and it's in the blue here, because it's the adjacent. So the blue is the adjacent, so that's the cosine, the x value. The opposite of theta is sine. And now I'll show you how you get these values. These values here are from special triangles, and I'll show you that in class later. Okay, so let's use the unit circle to evaluate exact values of trigonometric functions. Now I've put the unit circle here on the problem just to help us out. Eventually you'll know all these by heart. They're not really hard to memorize, and I'll show you some easy tricks in class to memorize these. But for now, and for the sake of just doing this problem, I'm going to give you the unit circle. So the first question is, find the exact value of cosine of 225 degrees. Well, the first thing I'm going to say is this. The initial side's always going to start here for your angle, okay? Now, 225 degrees is the angle that terminates right here. And just so you know, 225 degrees is also going to be 5 pi over 4, you can see here. Now, the question is, what's the cosine value at 225? Remember, we associate cosine with the x or y value. I hope you associate it with the x value. And the x value is here. And remember, in a ordered pair, it's always the x value first to y value second. So that's a really easy problem. You just look on the unit circle and you see, okay, cosine is negative 2 pi over 2. That's the answer to the first one. Now I'm going to erase this so we can do the second problem. Let me erase this really quick. Okay, the second question is a little bit more complex, but not that hard. So it says, what's the exact value of tan of 5 pi over 6. Now, if you're not that comfortable with radians yet, you convert that to degrees and you can kind of find it a little bit easier. But remember, the initial side of your angle is going to be along the positive x-axis here. And you can look on the unit circle and you can find 5 pi over 6, which is right here, which is also, it's also 150 degrees. Okay, now, tangent, you know, is opposite, tangent theta is opposite over adjacent. And you know the opposite's associated with the y, and the adjacent is cosine associated with the x. So to find tangent, you would just replace the y and x values here in this fraction and then just solve for tangent. So tangent of 5 pi over 6. And so if you can see, the y value here is 1/2. So it's just 1/2 divided by the x value here, which is negative the square root of 3 over 2. Remember, when we divide by fractions, we multiply by the reciprocal. So I'm just going to multiply this and then you can see the 2's will divide into each other, become 1. And then you multiply across it, so you get 1 over negative square root of 3. But you remember, like to rationalize the denominator, so I'm going to multiply both sides by the square root of 3 over 3. And that becomes a negative square root of 3 over 3, and that's my answer. Okay, try to do these 3 on your own, and I provided the unit circle. I'll also give you one in class as well. Then when you finish this, I will assign some classwork for you as well. Some of you will be working on your quizzes from yesterday that you didn't finish, and maybe making some corrections. Others of you will be listening to this video and finishing this. All right, thank you guys.